Okay, so if we go back to the revision, previous revision in chapter 1 and also in, I think in chapter 3, Okay, so you have this where you draw out the rectangular form, If you remember, we have sigma plus j omega. So sigma represent this value, okay? So in the real, and we have the imaginary. So basically when you expand it, you get in terms of sigma plus j omega, which is in rectangular form, equivalent to the polar form. So basically what you do is that you press the calculator, right? Okay, but you still need to understand how it convert from the rectangular form to the polar form, So basically this is I already explained, teach it in chapter 3, I remember. So you just refer back to that, how you get this equivalent. So the important is that we want to look at this Rej theta. So what does it mean by Rej theta? If you look at this equation, okay, R means that this radius lah kan, radius or distance, this distance. So basically this distance we have, and we have an angle theta here. Okay, so by having that, okay, so definition of Z transform, if you look at this, okay, previously we defined that E j omega is equal to R, right? So in Z transform, we can define Z, okay, in terms of R E j omega. So basically, if you look at how it is drawn, okay, you have the real value, imaginary value over here, okay. So real value is this one, okay, imaginary value, okay, and then we write it in terms of Z equal to E j omega. So just now we write it as R E j omega, right? R is what? This length, radius, right? Okay, and then we have the theta is basically this omega lah. Okay, so but if you look at this equation, okay, let me just delete that. Okay, if you compare it 1 to 1, what is the value for R here? R is equal to 1. So basically for Z transform plane, okay, how you write it is that for Z transform plane, we have a radius of 1 circle, okay, a circle. So we have plus 1, minus 1 here, plus 1 here, minus here, minus here. So it's a unit circle. So we call this as a unit circle. And for stability, okay, for stability to check if the system is stable or not, we are going to see that does your system Z will be more than the it will actually converge with the unit circle or not. Okay, so that one I will explain in the next slide. Okay, so what you need to understand is that how we draw this unit circle and why it's equal to 1. So it comes from this equation, Z equal to RG E j omega, whereby when you write it out, for Z transform, R is equal to 1. Okay, and why? Because that's the unit circle to check if the system is converged or not. Okay, so this is the Z transform equation table. So you have on the left side is all the signal in terms of time domain. So you have UN. Okay, this is why it's important to understand what you have learned in chapter 1. Okay, discrete time signal. Okay, so discrete time signal, you have all the signal in terms of shifting, reversal. So let's look at one example. So the first signal is what? Delta n, impulse. Second signal is unit step. Third signal, is a unit step. Okay, UN, and then n, and then basically you have a unit step that has a shifting n minus 1, shifting to the right side, okay, delay, and then you have that unit step reversal because minus n, okay, and then after that you have minus the whole thing. So basically you have amplitude. Amplitude pula. Yeah, and then we have the amplitude transformation. So you reverse it down. Okay, so you can look at the other example with blah 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 and so on. Okay, but the important is that to understand. For example, if you look at if your later we will actually convert from discrete time to the Z transform. Okay, Z transform will be labeled as this, and you will see on the right side you have the additional table or column. Okay, for Fourier transform we don't have additional column. We only have the signal, okay, continuous time, and we have the Fourier transform table conversion. But for Z transform, we have an additional, which is ROC, region of convergence. So if you look at here, is that it says here, for example, Z more than 1, Z less than 1, Z more than alpha, Z less than alpha. So what does it mean? Later we do an exercise and you will understand that. Okay, so we go to the next one, is region of convergence. Okay, so by definition, if you look at this, okay, based on the book, the signal system book, okay, so it means it's given here is that the set of values of Z for which the Z transform converge is known as regions of convergence. Okay, so means if you look at the explanation for Oxford dictionary, so convergence means that the process of oscillating or converging. So if you are driving, you're driving your car. So what does it mean by converge? If you have two lane and it's converge. Accident. Converge means that merge lah. Merge. Converge doesn't mean accident. Converge means that it merge or later it will going to overlap, merge together, right? So here it says that the fact that two or more things either become similar or come together. Okay, it come together doesn't mean accident. Means that you actually converge. It's in KL example, lots of lots of the lane are converging, right? Two lanes suddenly split. Two lanes suddenly combine. Okay, but you still have combine it into two lanes. It doesn't actually converge. Two lane become one. Two lane from different lane converge become two lanes but in the same direction. Okay, cannot understand. So this line is the lane, one lane, second lane. Okay, and in the end you have two lanes car lah. Okay, two lanes lah. No, let me just example lah. Okay, payah lah. No, not accident. This is two lane. Ayah. Ayo, that's not accident. Two lane. One lane become two lane. Sometimes two lane split become one, become the combine into different lane, right? So in KL there's a lots of lanes like that. Okay, if you sit in the wrong lane, then basically you need to U-turn or go through a toll, pay extra toll and so on. Okay, so converge means that it is going to overlap lah, basically overlap. So let me just delete that. Okay. Okay. So next, the important rules of region of convergence. Okay. So it says here is that if the region of convergence means that the merging, okay, include the unit circle. So you have this, okay, unit circle at r equal to 1, r equal to 1 here, okay. So basically, it says here, if it include the unit circle, then the system is stable. Okay, so let me just write that. Oh, I have been in this. Okay, so unit circle, right? Minus 1, 1. So basically, this one is unit circle. Okay, so you write it like that. So you can write it as that plane. Okay, so it says here is that the first one is, if the ROC includes unit circle, then the system is stable. So let's look at the Z transform table just now. Okay, this one. Okay, if you look at number 5, this one, number 5, okay, example, alpha n un, okay, given by this equation, I'm going to just look at the region of convergence over here. So Z ROC is Z more than alpha. So basically, what it means that alpha value will be inside this equation. So if I'm writing it out, so example here is Z equal to 1 over 1 minus alpha inverse Z, right? Okay, so you can write it, if let's say alpha is a value, okay, you can, is a value, example this alpha is equivalent to 1 over 2. So you're going to write this equation as 1 minus 1 over 2 inverse Z. Okay, whereby the Z is just follow this. Okay, so you have more than 1 over 2. So 1 over 2 is where inside this region of convergence. From circle, 1 over 2 minus 1 over 2. So how do you draw Z more than 1 over 2? Means that you have terms like this, and it's actually going out lah. Okay, going out basically to infinity lah, because it's more than 1 over 2. So thus this region, okay, we look at the statement just now. Okay, this one. If ROC include the unit circle, the Fourier transform table is stable. So does the ROC Z cover 1 unit circle? 1 is where? Here, right? It covers, right? Tak faham. If you draw this one, Z more than 1 over 2, how do you draw it?
It's away.
Away, going out lah. Going out. Okay? Going out. The one that I'm actually plotting here is, means that Z more than 1 over 2. Inside, I didn't actually make the any sketch. I didn't sketch it inside. I only sketch it 1 over 2, Z more than 1 over 2. Okay. If cannot understand also, okay, let's say that you have an explain, okay, 1 over 2, okay, 0. If, for example, if the explain, okay, more than 1 over 2, how do you plot it? Like this, right? You plot it towards the right side. Okay, same thing, but this is unit circle. So you have 1, that's why you have Z is modulus. Okay, you have plus minus lah basically. So you have it on plus and minus, and that's why you have also this one is plus and minus. So you have 1 over 2 and minus 1 over 2. So Z more than 1 over 2, then you plot it, sketch it outward. Okay, ROC means that it's going to plot outward. Okay, this one is not what I'm supposed to draw, but to actually show you how you plot it, ROC. Okay, so this is one. Let's say that ROC is 2. Alpha is 2. So alpha is 2 means that alpha change with 2. And by looking at the table just now, basically you write it as Z is more than 1/2. So 1/2, how do you draw this? The region of convergence. Unit circle. Unit circle. Is Z plane. Real. Imaginary. Okay. Where is 2 inside this plotting? Where? Draw it. Because I feel that students don't know how to draw it. Okay, where is 2 in that plotting? Where is 2? So basically 2 is just how you draw a coordinate. How you draw a coordinate? Their flavor is 1, 2, 3, 4, blah, 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 until infinity. Minus 2 until minus infinity. That's how you draw. Okay, so basically we have 2. Where is 2? Here. Minus 2 here. Why you need to put 2 and minus 2? Because here is modular. Means that basically you have 2 value. Plus 1, plus 2 and minus 2. So that's why you have plus 2 and minus 2. Okay. So draw that. It says here that Z, the region of convergence, is more than 2. So plot upward. So now the region of convergence is ROC, Z is more than 2. So question is that this one, is it stable or not based on the first statement? Not stable lah, because it doesn't cover the unit circle. Unit circle is here. Okay? So we call this as Z more than alpha is basically an outward type, ROC. Outward type. Okay? There are the 3 types. Outward type, outward, inward, and donut type. Donut is like donut lah. Okay? Means that, let's see how the donut looks like. It's like donut actually. Okay? So, here, if it does not include unit circle, then it's not converged lah. Means that it's not stable. Okay? So let's look at this one. Okay, this one is just to actually recap again what you have learned in control subject or in Laplace. I believe that you took it during Laplace in what subject and differential equation? Engineering Maths 1, 2. Differential equation. Okay? You have that, right? Laplace. So when Laplace or even control, basically in control subject, if you remember, you plot Rod-Lucas. Have you learned that? Rod-Lucas, So you're going to plot the poles and zero on the plotting, Rod-Lucas plot. So basically, when you plot, when you find that it's on the left side, most of the time the system is stable. If it's on the right side, then system is unstable. So similarly, okay, so how you write the equation for Z transform will be similar to Laplace that you have learned. Instead that S is going to be written as Z. So you have XZ equivalent to PZ over QZ. So basically it can be any equation lah, YZ over XZ. Okay, so the top one is the numerator, okay, which is zeros. And then the bottom part will be the numerator, which is the poles. Okay. And if you see on the right side, it's all just a recap on what you have learned in control subject. Okay. Control subject, if you remember, you have the general equation, you have over them, under them, and critical them. So you can see that if it's plotting on the left side, system stable, okay? System on the j omega, which is imaginary, system become unstable, okay? Unstable means that it's not going to stop, okay? This one you stop, you have overshoot, and then afterward it will stop. Here it's going to be underdamped or oscillate lah. And last one is that critical time, which is still stable. Okay, so similarly, okay, for the Z transform, this is what I explained just now. Okay, you can actually plot if a system is stable or not based on the region of convergence. Okay, so the first one that I have explained is the stable system, whereby when the region of convergence cover the unit circle. So inside here, the unit circle is labeled by the red color line, circle. Okay, so this one is equation for if it's Z more than A. Okay, so you have A here. Another one is that also Z more than A means that it's an outward type. Okay, so this one, the unit circle does not, the region of convergence does not cover the unit circle. Okay, unit circle is red color. So when you sketch it, it doesn't actually cover the unit circle. So this is unstable. Okay, so there are three types of ROC. The first one that I explained to you is the outward type ROC. So it means that the sketching is going out from the center, going out. Okay. Second, okay, so the ROC is given by Z more than A. Okay. Second, ROC is inward type. So inward type is when you have this type of ROC. So if you look at the table, which one shows Z less than alpha? Equation number what? Number 6, right? Number 6 over there. Okay. So the equation number 6 is given by this one, minus alpha un minus blah 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 and so on. So the region of convergence is less than alpha. Okay. So looks the same for the Z transform here. It looks the same. Later we will try to derive why for this discrete time you actually get the same equation, but the region of convergence is different. Okay, so this one is second one, region of convergence. Third is, we call it as the donut type or ring type ROC. So basically you have both combination of Z more than A and Z less than B. For example, A and B is just a value here. Okay, if you have the unit circle at 1 here in the middle, so basically you're going to plot, if A is, example, let's just write here. ROC Z more than A, okay, and Z less than B. Let's say A you have 1/2, okay, and for B is you have 2. Okay, so if you draw it out, okay, 0, unit circle, so 1/2 is where? Here, right? So which is this? This 0.5 minus 0.5. Another one is 2. 2 minus 2. Let's sketch the first one, region of convergence for Z more than 1/2. So Z more than 1/2 means that what? You have like this, right? So It means that it's going outward, right? Outward. Okay. Another one is Z less than 2. Means that it's going to inward. So inward. So basically, when you sketch it, okay, means that if you draw it separately, basically you are going to check which of the two region of convergence is overlapping. Okay, of course for Z more than 1/2, when you draw it out outward, it will have this one, right? Moving out. But for the Z less than 3, less than 2, there's no region of convergence outside here. So we don't take that region. We need to take the region when two regions overlap. Okay, so therefore, based on this, when you want to plot the region of convergence, you plot it like this. So it looks like a ring type or donut type. Okay, and basically ring type, donut type, you can identify it when you have one is more and less. Okay, so you get it in terms of donut type. Okay, this one, so based on the region of convergence, okay, look at the first one. So first one we have done, we have identified that the first one is ROC upward type. Okay, outward type. And for outward type, it's actually the equation given by is ANUN, which is right-sided sequence. Okay, so right-sided sequence means that you have the signal only in the positive side. If you look at this one, XN, ANUN. The N is just value. UN means that you know that step is starting from 0, right? Until positive infinity. The other value is 0, 0. So we call this as right-sided sequence. Okay, right-sided sequence. So for right-sided sequence, most of the time we have the Z more than R, more than A lah, the value. Another equation is that you have a left-sided sequence. Okay, left-sided sequence is given by, don't look at this AN, look at only this one. U minus N minus 1. If you plot this, what do you get? Here or here? Here. Here. So using tab lah. Okay, let me just because you want recording, let me just open. Oh, easy to see. Okay. Wait, Okay, so we go to the first one lah. First one, Okay, first one is right-sided sequence. Okay, second one is left-sided. Third one is left-sided plus left plus right-sided sequence. Okay, so I'm not going to derive everything. I'm just going to explain what does it mean by right-sided sequence. Okay, so right-sided sequence is given by this equation. Okay, and the region of convergence is given by this one. Okay, you cannot see it maybe. So region is convergence is given by Z more than A. Okay, for left-sided sequence, the region of convergence is given by Z less than A. Okay, and the third one is region of convergence is given by Z more than A less than more than B. Okay, so let's look at the first one, right-sided sequence. RSS. Okay, so it's given by X n equivalent to A N U N. Okay, so basically what you do is that, okay, so we are going to look at this one only. I'm not going to prove it yet. Okay, I'm looking only at the UN value that you have. So when you plot UN, what do you get? The signal. You have it in terms of 0, -1, -2, 1, 2, 3, right? So signal UN is a step signal. This one is 0, 0, 1, 1, 1 until plus infinity. Okay, so right-sided sequence means that the signal step from 0 and goes to positive infinity. Okay, so this is what it means lah. So anything that on the right-sided sequence, the ROC Z will be more than A value. Okay. Later, it will make sense later on when you do an exercise. So, but I'm just going to explain first on this. Secondly, okay, is left-sided sequence given by the equation xn equivalent to minus en u minus n minus 1. Similarly, we are going to look at this part only, the one that highlight blue color. Okay, so the one that I highlight blue color, okay, how do you draw the signal? Okay, you have 0, minus 1, minus 2, minus 3. Okay, 1, 2, 3. So you draw this. This is why important chapter 1. Okay, if not, I'm going to explain it. It doesn't make sense at all. Okay, so this one is a unit step. Why? Because U. Okay, so it's a step signal. And the step signal have what transformation? Shifting, which is the delay. Okay, and then what else? And then you have a reversal. So you have shift and reversal, then we do what first? Shifting. So if you have shifting, I'm not going to write out the UN. Directly we do a shifting. So basically you have the unit step, then shifting by 1. So basically we write this, right? Towards plus infinity. Right? And then we need to do the reversal. So we do the reversal. Okay, reversal. Minus 1, minus 2, minus 3. Okay. Reversal means what? Flip. Flip it. Basically, it's like a mirror lah. If you look at your face, then it's going to flip whatever. If you comb it right side, sengit kan? Okay. Shorter or what? You cut your hair, right is shorter and longer. And then you flip. What happened? It become a different amplitude, right? A different length lah. Okay. Amplitude. So, basically, this one, you flip it. What happened? 0 still 0, right? This is 0, 0, 0. 0 will still 0. Why? Because we flip it at n equal to 0. Okay? So, flip means that flip this. Okay? Flip it. Like a mirror. So, you have the signal on the negative side at minus 1 become 1. 0. Minus 2, 0. So, up until infinity is 0. The positive part, 1 become minus 1. 2 become minus 2, minus 3 until minus infinity. So if you look at this, it become a left-sided signal on the left side. So this is what it means. So basically, if you look at the equation, it has u minus n minus 1. It's a left-sided sequence. And for the left-sided sequence, the ROC is given by Z less than A. Okay. Equation number 3, which is this one, is given by, if you have in one equation, okay, number 3, let me just write it here. Number 3, okay, we have both LSS plus RSS. Okay, so what does this mean? We have both lah, the equation. So Xn, you have combination of the right-sided sequence. So right-sided sequence, example, I'm going to write it in the correct way. So you have right-sided sequence plus left-sided sequence. So right-sided sequence is A N U N, okay, and the left-sided is minus N U minus N minus 1. So this one is the right-sided. This one is the left-sided. So basically, when you have the equation like that, then you know that it's going to be a donut shape lah, or ring shape type ROC. Okay, if you only have the right-sided equation, then it's going to be only one side lah. It's either outward or inward. Okay, so this is a concept that you need to understand. Okay, any question? At the back there? Okay. Kosila? Okay. Syahir Amir? Syahir mana? Cuba cabut tu earbud tu, boleh? Okay. Lepas ni jumpa saya, lepas kelas. Jumpa saya. Alright. Okay, next. Okay. So this one is just the same thing that in the previous slide. So basically for the Z transform, you have using the equation exact. Okay, exact. Okay, the numerator. This is numerator over denominator. Okay, so numerator we call it as the zeros. This is poles. Okay, poles is basically you label it as X. Zero is 0 lah. Okay, so and in this case is that if you look at this, it also mentioned that, okay, the Z transform may be one-sided or two-sided. Okay, basically the one that I explained just now. Okay, means that one-sided or two-sided kan. Okay, so if you look at this explanation, okay, the Z transform may be one-sided, which is one-sided is what just now. One-sided is it's either right-sided sequence or left-sided sequence. Okay, or it have two-sided. Two-sided means that they have both lah. Okay, right and left. Okay. Okay, so and right and left, how you write the equation will be different. Okay, so let's look at the equation for I'm just going to take this. Okay, okay, small or okay, okay, at the back there, right? So let's look at the definition that it says here. Okay, for now, if you look at this unilateral, unilateral means that one-sided lah, one-sided. Bilateral means that two-sided, okay, and then it's given by this equation. This equation. How do you get this equation? So this equation, we get it from the equation of Z transform. So Z transform equation is in this one. This one. Okay. The equation exact So this is Z transform equation. So given by, if you look at it, okay, you write it as x z, okay, summation of n start from 0 to infinity, okay, x n, okay, or you can write it in normal bracket, z minus n. Okay, so unilateral means that if you look at this equation is unilateral. Why? Because you have n from 0 to infinity, right? Summation of 0 to infinity. Another way that you can write it also, this one, of course, is for the right-sided sequence. For the left-sided sequence, how do you write it? You have minus infinity 0, xn, z minus n. So this one will be the left-sided sequence. So many sounds. Okay. And then lastly is bilateral. Bilateral means that both sides. So from this equation, both sides, you know that you have the minus infinity to infinity, right? Because you have both sides. So for right-sided sequence is basically 0. Okay, you have right side. Okay. Left-sided means that from 0, okay, you only have the left side. Okay. For bilateral means that you have both sides, right? You have the left side and right side. Okay. So basically, it covers both minus infinity to infinity, x n, z minus n. So this one will be right-sided plus left-sided. Okay. Take a break for a while. Take a break. It's already 9. 10 minutes break. I'll come back at 9:15. Next slide is example 1. So let's do example 1. Okay, this is just to show you. Let's say you have a right-sided sequence. Then how do you get the ROC in Z more than A? Okay, so alright. So let's start now. Okay, so the example given is determine the Z transform of signal xn. So given, okay, I'm not even try to ignore that plotting because that plotting is actually wrong. I don't know how it was wrong because I took it from the book but if you look at this, do you think it's wrong, the plotting? Sn equal to un. Un, how do you plot? How do you plot? You actually have the plotting to infinity okay, to infinity. I don't know why. This one I didn't draw it, but I took it from a book, but the plotting is like that, so it's wrong, basically. So just ignore that. Okay, don't follow that. Okay, so let's say that we are just referring to the statement there. So given xn is equivalent to un. So basically it says there that you're given a signal xn, which is a step input. Okay, signal. So step input signal, let's say that we are going to draw that step input. Understanding that what is step input is important. So you have 0, minus 1, minus 2, minus 3. And then you have 1, 2, 3, 4, 5, until infinity. Okay. So means that for unit step, at 0, you have a value, right? 1. Less than 1, less than 0, you have 0. So the other signal, you have 1, 1, 1, 1 until infinity. Okay. So if you notice in assignment 1, you also learn that you can actually write this signal as a discrete time value. Okay, so how you write it is that you have 0. Sorry. You have 1, 1, 1, 1, 1, until positive infinity, right? Remember? In the assignment? Okay. Assignment, instead of they give you an equation, you are given in this equation xn with a value. And that in the equation, t equal to 0 is labeled as the underline. Okay. So underline there means that this one is at n, sorry, not t, n equal to 0. So basically n equal to 0 is 1, 1, 1, 1 until infinity. Okay. So based on this, the equation is that determine the z transform of the signal xn. So we are going to use z transform equation. Okay, so solution. So z transform table, what is the equation? X z equivalent to xn, summation of minus infinity into infinity xn z minus n. Okay, so this one is the equation, the z transform equation. Okay, correct? Check please. Okay, it's correct, So if you look at the plotting over here that you have plot, okay, so we are going to substitute the value. Okay, so xz is equal to summation of, you have starting from where? 0, 0, right? The rest is at n equal to 0, you have value, so n equal to 0 until infinity. Xn is equal to un. Okay, substitute that un, z minus n, minus n, minus n. Okay, I'm just going to follow what the equation given, and un, you know that un is given by, the amplitude is 1. Okay, so when amplitude is 1, then you can actually substitute it, and then you have summation of 0 to infinity z inverse n. Okay, okay, according to mathematics, okay, according to maths equation, okay, for summation, okay, boleh faham tak? Okay, according to mathematic equation, okay, for summation, boleh faham? Okay, you are given, this is mathematics, okay, so you are given summation of n equal to 0, infinity is equivalent, a to the power of n equal to 1 over 1 minus a. Okay. Okay. This one is like a Euler identity lah. It's fixed. Okay, so fixed. Now let's compare with what we have derived so far. Can we actually put it into this term? Yes, right. So you need to put it in terms of n value up there, right? Okay, so let's rearrange it. 0, infinity. Belakang nampak size font tu? Okay. And then you have z minus 1 in bracket n. Betul? So what's your A over here? Based on this. Your A is equal to z minus 1. Okay. So what you do is that we know that according to the math equation for summation, you can write it as 1 over 1 minus z inverse 1. Okay. If you want to know how this one get this one, you need to ask the mathematics lecturer lah. How they derive it. I'm not a mathematics lecturer. Okay. If mathematics lecturer, maybe they can actually prove to you that this one equal to this one. Now I'm just proving the equation for Z transform. Okay. So using what we have. Okay. So we have 1 over 1 minus Z inverse. Okay. So if you remember, you have learned in control subject. The numerator under here we call as the characteristic equation, right? Characteristic equation. Okay. Boleh lah. Characteristic equation. Okay. Alright. So, okay, therefore, ROC, okay, we take the characteristic equation, 1 minus Z inverse 1 less than 0. This one fixed. Whatever you have characteristic equation, less than 0. Okay? Right? Follow? Boleh follow tak? So, this one is the characteristic equation just now. This one. Okay? This one. So, less than 0. That's how you write it to find ROC. Okay, so we just rearrange it so that you are much more easier to actually rearrange it. What is ROC? So 1 minus Z inverse 1 is 1 over Z. Less than 0. Okay. If we bring this 1 over Z to the right side, what do you get? How do you write it? 1. We are going to inverse the symbol, right? Okay, you get 1 over Z. Okay. Therefore, you can write it as Z. Bring it up here. More than 1. Okay. So from here is that just now, the one that we go through, right-sided sequence, what was the ROC from the table? Z more than the value A. So now we just prove it. Okay, that Z is more than 1. Okay, so and normally when they ask about ROC, normally we need to draw out the region of convergence with the unit step. Okay, so draw it. Okay, where is 1? 1 minus 1. Okay, this is a real, imaginary, and then this is Z plane. Don't worry, we have time. Z plane. Okay, ada 30 minutes. Okay, so Z plane, draw the unit circle. Okay. And for this case is that 1 is 1. So you have more than 1. Okay. For this case, we still say that the region of convergence is stable because it's crossed at 1. So, stable. Right? Can follow? Okay. Let's do a very quick one. Just to prove it for another equation, which is different a bit. We have xn, an in a to the power of nun. If you look at your okay, if you look at what you did just now, what did we prove just now? Un value, un value, right? And the ROC is z more than 1. Okay, now we try to prove this one, an un, okay, which is this example. Okay, so using the same method, so find question A, find exact. So exact, basically we are, of course, later on you're going to use directly Z transpose table. I just want to actually prove to you that why it's like that, okay? So we do a few derivation, then later we just directly use Z transforms, similar to Fourier transform, So exact, what is the equation? Summation of minus infinity to infinity, xn, z minus n, right? Okay, so just substitute the value of xn over here. So xn value is this one. Okay, so you get, and xn value is an un. Okay, so an un means that what? So substitute first, minus infinity to infinity xn an un. Okay, and then z minus n. So this one is xn lah. Okay, follow? Okay, now is the tricky part. Okay, you know that the signal itself is a unit step, which is it a right-sided secant or left-sided? Right-sided, right? Right-sided, why? Because if a unit step is start from 0 and then it goes to the right part only, kan? Alright? So basically, you have the summations from 0 to plus infinity. So we can actually rewrite again this equation to summation of 0 to infinity an. Okay, un is 1 value. Okay, z minus n. Anyone don't understand how I got this? How actually from this become this? What happened to un? What happened to un? Un, we already understand that it's the right-sided sequence. 0 to plus infinity, right? And then because of this, we change it this one. 0 and infinity. The original equation is minus infinity to infinity. Okay. So by understanding that you are going to do summation only for the right-sided. Okay. So we do it from 0 to infinity. Okay. Therefore, un disappear because we already translate it into 0 to infinity over here. Can you understand? Okay. So after this, what we do is that we rearrange again. So 0 to infinity, what? Z minus 1 power of n. Why? Because we want to make it in the equation of summation just now, right? The equation of summation, what was it? According to the mathematical equation, so summation of n equal to 0 to infinity, an equal to 1 minus a. Okay, this is the equation. Okay, so what is your a over here? What's your a? This one, right? The whole thing. Can? Okay, so you can write into this equation. So 1 over 1 minus a inverse z. Okay. So this is exact. Therefore, ROC, okay, can be written as what? We take the characteristic equation. Characteristic equation is which one? This part. Okay. This part is characteristic equation. Okay. So characteristic equation less than 0. So 1 minus a inverse 1 less than 0. Can follow? At the back there? Aganit mana Aganit? Can follow Aganit? Bangladesh? Where are you? Okay. So 1 minus, rearrange it, a over z less than 0. Bring this to the right side. Okay. 1 a over z then you get z more than a. ROC. Okay. So what we did just now is we proved that for a to the power of n un, you get the ROC is z more than a. Okay, which means this table, this one alpha n lah, basically a n lah, un, the ROC is z more than alpha, and whereby the transform just now you get is 1 over y minus az inverse z. Okay, so you prove both the z transform here and ROC. Okay, inside this is the explanation also. Okay, so let's say for the ROC, because we have only e value, kan? So let's say we take a value. Let's say let's say a equal to 0.5. Okay, so basically how you write xn is xn equal to 0.5 n un, whereby hz you get 1 over 1 minus 0.5 over z. Okay, because from this equation just now, the above, okay, an un, right? So n you have 0.5. So basically this is z transform. So you can actually substitute only the value of a. Okay, so you have 1 over 1 minus a inverse z. Okay, so basically in the exercise later on, you're not going to derive it lah. Directly look at the table. Okay, and then after that we are going to determine what is ROC. For this case, ROC, just look at the table. ROC for alpha and un is more than a. Okay, so ROC z is more than 0.5. So if you draw it out, draw the ROC. Minus 1, 1. 0.5 where? Here. 0.5 minus 0.5. So Z more than 0.5, so it's outward. Outward. So outward means that, does it cover the unit circle? Does it include the unit circle? Yes, right? So you are going to color it something like this. It's going out. Okay? So when it cover unit circle, system is stable. Okay? Cover means that overlap. Because you plot it Z more than A, so it overlap. It goes to infinity lah basically kan. Okay. Okay, that one is one example if A is equal to 0.5. Let's see that if in the equation A is given by 2. Okay, 2. So basically, the original equation was what? X and A power of n un, right? So just substitute value 2 and un. So this is the equation given xn. Okay, using Z transform. Okay, using Z transform. Okay, means that you can directly refer to the table. No need to derive. Okay, we just jump directly to table. After understanding why for a to power of n un, you get the transformation here and the ROC here. Okay, then we just look at the table. Okay, only then it makes sense lah why you do this exercise. So what you do is that you need to identify what is the ROC, right? So ROC is Z more than 2. So draw the ROC. Minus 1, 1, minus 2, 2. Okay. Macam mana jadi macam tu pula. Okay, and then 2. Like that. Okay. So Z more than 2 means that outward lah. Outward then. Outward. Okay. For this case, does the ROC cover the unit circle? No. So when it doesn't not cover, then the system is unstable. Unstable. Oh, very bad. Unstable. Okay. Actually, during my school days, my teacher say, Mariam, please write properly. I cannot read your handwriting. Okay. Alright. Sure. I'll try to write properly. Okay. So this is like my handwriting since back then lah. So it become more worse lah basically. Okay. So can understand that one, Okay. So the other slide is just explaining it. So similarly, but I'm not going to explain this. Similarly, you can try to do this one. A to the power of minus n. Same concept. Try to find out what is the ROC. Is it Z more than A or Z less than A? Okay. We will continue this tomorrow. And another example is, example 3 is another example whereby example 2.2 is still a right-sided sequence because un, right? Okay. Example 3, if you look at it, is it left-sided or right-sided? Left-sided, because you have un, this one, un minus n minus 1, So you basically have the left-sided. So this one is also wrong. I don't know why the book is wrong, Okay, minus infinity, So it goes to infinity. Okay, at 0 point you have a 0 lah. Okay, so this is left-sided sequence. Left-sided sequence is a bit difficult. I don't think that I'm going to derive it. I have the derivation, but I think it's a bit complicated lah. Too complicated lah. So no need. We just skip that. Okay, so what we are going to do, Later on, you just need to know that this is left-sided sequence, and for the left-sided, the Z transform is given by this, which is same thing, 1 over Z minus A equals Z, okay? And Z is less than A. Okay. If you look at this, actually this equation is also written as 1 over 1 minus A inverse Z. Okay, same thing as the right-sided. Why become here? Become like this is that you divide both with Z over Z. So you get 1 over 1 minus A over Z. Okay? So we stop here because I look at your face, it's like cannot tahan anymore. Cannot tahan. So basically, what we are going to do tomorrow is this example directly. Just have a look for a while. So if you look at this one, what type of signal you have? Right-sided or left-sided? Right-sided, eh? How many right-sided sequence you have? 2. Brilliant. Okay, now you understand between left-sided and right-sided, eh? So where is the right-sided sequence? Why is right-sided sequence? Because you have UN. So this is the first equation. Second equation is this one. Okay? So based on this, we are going to convert it directly with Z transform table. We just look at the table directly. And then what we do is partial fraction. And then we plot the ROC. And then we convert it back to XN because the question asks you to get in terms of XN. Okay? So we do it tomorrow. Okay, that will be all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.